All right, number 16. Number 16 says the concentration of LiOH, or lithium hydroxide, is 0.5 molar. Remember, molar just means moles per liter, right, or molarity. So if 25 milliliters of our lithium hydroxide is needed to titrate 40 milliliters of our nitric acid, what is the concentration of HNO3? Excuse me. Okay, so it's our titration question. So what does the titration mean? Well, all our titration means is that we're getting to the point where our H is going to equal our OH, right? Because let's do a little thinking here. If I had something like HCl plus NaOH, right? HCl is a strong acid, NaOH is a strong base. If I react these two, well, we all know you should make water plus NaCl, right? So let's assume I got these to titrate, right? I got them at their equivalence point. This is called our equivalence point. So that would mean, let's say I had 10 moles of this and 10 moles of this. If I broke these up, right, remember these are strong, there's a strong both of them, so they're going to both break up they're going to break up 100% in water. So I'm really going to get 10 moles of H, 10 moles of Cl, 10 moles of Na, 10 moles of OH, right? So if I have 10 moles of H and 10 moles of OH, I'm going to get 10 moles of H2O. And if I have 10 moles of Cl and 10 moles of Na, I'm going to get 10 moles of NaCl. That's our titration point. It's the point where it's going to equal our H and our OH. That's a little background on that. Okay, so with that being said, we know our concentration of our LiOH is 0.5 molar. And we know it takes 25 milliliters to titrate. Okay, so what does that mean? That means, so I have 0.5, let's write it like this, moles per 1 liter of LiOH. And it takes me 25 milliliters to titrate, which is going to be the point where my H is equal to my OH. So 25 milliliters, if we go ahead and divide that by 1,000, right? Make sure I'm on the right problem here. Yep, okay. So if I divide it by 1,000, I should get 0.025 liters. Because remember, we need to be in liters. We can't multiply molarity times milliliters. So that cancels that. And that will give us our moles of LiOH, which is 0.0125 mole LiOH, right? Okay, so this is actually the point. So this is the amount of moles of LiOH I have, which is also the amount. So if we see here, let's do a little stoichiometry so you guys can go ahead and see what I'm doing here. Mole of LiOH. Well, I know for every 1 mole of LiOH, I have 1 mole of of OH. Right? For every 1 mole of this, I have 1 mole of that. Well, I'm at my equivalence point, so I know for every 1 mole of OH, I have 1 mole of H. Right? And since we're going to that nitric acid, which is what the question is asking for, the question is asking what is the concentration of our nitric acid? Well, I know for every 1 mole of H, I have 1 mole of HNO3. So mole of LiOH go, that cancels there. Now we get moles of HNO3. So that was pretty much the entire problem right there. Because we see that we're just multiplying everything times 1. So if I had 0.0125 mole of LiOH, that's also the amount of HNO3 I had. It's not always going to be 1 to 1, right? Because if I could have had something like sulfuric acid here, it would have changed. So you gotta actually go ahead and do your stoichiometry. Okay, so now our question is asking for our molarity. Well, remember, our molarity is just moles over liters. I have the moles, and they gave me the liters, but they gave it to me in milliliters. So it's really 0.04 liters. And if you go ahead and divide that out, you should get 0.3125 molar HNO3, or answer choice number 3.
The Teaching Center, UF's Learning Resource Center.